Hi, my name is CJ Craig, and I'll be presenting Word2Vec in Python using Gensym. First, we're just going to conceptually explain um, Word2Vec in Python, and then we're going to see how it's done with a basic application using the Gensym package in Python. So, just a brief overview of word vectorization in general. A common application is kind of like the bag of words example, which is like the simplest method, which basically uses one hot encoding. An example of this would be if we looked at the sentence "march down the alley," um, in which we want to encode alley. So then we can look at our vector, which would be one hot encoding, which we can see 0, 0, 1. This is okay for term frequency or TF-IDF formatting, but it's really not scalable in terms of correlation analysis or any other type of word analysis that we'd like to do. So we're going to look at another method known as Word2Vec. So the brief overview or history of Word2Vec. It kind of started in 2013 from an engineer at Google named Thomas Mikolov. Um, there's kind of like a timeline of word vectorization. Um, and so this kind of falls in the later years. There's still been improvements since then from Word2Vec, but I'd say Word2Vec, from what I've seen online, is still one of the most commonly used word vectorization techniques. So this was an improvement from latent sentiment analysis, which basically uses a document term matrix to evaluate correspondence of terms, and also using like derivative functions and stuff like that. And stuff that has come out after Word2Vec is the glove model, in which was started by Pennington, Socher, and Manning. And Manning actually has an information retrieval book if you're interested in that. That's the book that's used at DePaul under CSC 575. And then per token representations is also another newer model that has been used. So the general idea of Word2Vec or word vectorization in general is that you want to look at word embeddings that changes a word to a vector of numbers. So for example, tiger, we can see 0.4, 0.5. We can just see like the weighted vectorization of this word. Then we can use this association with another words to see what it's most similar to. A common example of this is using like a text data set with the vocabulary king, queen, woman, and man, and then we can see with this vectorization that we create. Looking at the data frame king and the data frame man, and the, minus man plus woman, and then that gives us the response queen. Also, looking further into the general idea of Word2Vec. So essentially, it's a two-layer neural network that has the input of a word that is converted to a vector. This allows basically, as we showed on the last slide, for ease of comparison. And you can perform similarity measures on the words. So that example was a linear relationship that I showed earlier. So you can find basically similar words by subtraction or even addition and subtraction. So that earlier example was kind of just showing the linear relationship of Word2Vec. Word2Vec uses two algorithms. The first one we're going to look at is a skipgram algorithm. It's more focused on context, and it's basically to learn the word vector, not the word itself. So yeah, it focuses on the context around the word. And so you need to find the neighboring words, with the hyperparameter being what is defined as the neighboring words, or also known as the window. So in our example below, we can see riding bikes in the sun is hard. So you can see the training samples taken away from that are the words surrounding it in the window of in the window of W minus 1 and W plus 1 and W plus 2. So we can see bikes riding, bikes in, and bikes the. And then in our next example, we can see riding a bike in the sun is hard. And so again, we're looking at W minus 1, W plus 1, and W plus 2. And so the training samples taken from that is sun the, sun is, and sun the. Or sun hard. That should be different. So another training algorithm is the continuous bag of words, which is focused on a target from the context bag of words, like bag of words. And so you're kind of looking at a target variable. And this is causes an issue, I guess, with less frequent terms. So in this statement, riding a bike in the sun is common words, hard and difficult, not common words, egregious, arduous, which are less common. So it'd be harder to predict that using the continuous bag of words. Look further at the next slide. So what's the difference between bag of words and continuous bag of words? Well, bag of words, we can help explain this by showing what bag of words is kind of not. So bag of words concept is similar to the one-hot encoding example that we saw in the first slide. Bag of words doesn't take into account similar meanings of the statement, in which continuous bag of words would, because you're looking at the target. Bag of words does not take into account the order, in which continuous bag of words does. So, for example, bag of words in the statement, the sun is hot, hot equals hot is the sun. And this can cause an example, or kind of cause an error when you're looking at, like these examples would basically be orthogonal in the continuous bag of words statements, so that they wouldn't be equal with continuous bag of words. So with Word2Vec, skipgram versus continuous bag of words, just to review, skipgram predicts the context, but better performance with less training data, and can find rare words or phrases because it's taking in that context. Continuous bag of words has a better seed than skipgram and can have increased accuracy for the frequent words. The most important takeaway is that Word2Vec implements both of these methods. That kind of wasn't commonly stated on research that I was doing on this topic. So, just to go over a quick application of this in Jupyter Notebook with a 10K report using the GenSum package. We will look here. Cool. So what I'm looking at is our as our data is a PDF file, and so I can go and look at and grab that PDF file real quick. So I can look at capstone, and then so this is the PDF that I will be looking at. It's kind of a 10K report of the XPO logistics company. And then we are going to be pre-processing that data using these list of packages in the NLT K corpus, importing stop words, importing word tokenization. And then essentially this function here, you're taking in different like exploratory analysis of the text document. And so an example of that, I guess, would be we can look at the number of words compared to another 10K report, the number of sentences, the number of images. And this was used kind of as a pre-processing step for our project that we were working on for the end capstone goal. And so, looking at the keywords of this in our main data frame, we can see the different words here. In Word2Vec, you're going to want to create an array for this. And the way you do that is by looking at the values of that. So you see here, this creates the array. And then you need to create tokens for these words. And so you do that through here, and you create your vector right here. And so when applying Word2Vec, you need to do a minimum count. So this is the minimum count that shows the occurrence in the text. So if you look back up here in the Groot XPO, you see all these at 1, these would be taken out. And then anything above 10 words would be included in. And then our vector size, we did 32. This is just something that I saw an example of this, and I think it's somewhat standard. I need to look further into the pros and cons of a smaller and larger vector array. So here is our vector. If we look at revenue, we can see that it's a size 32, and it's basically translating revenue into a vector space, into a word of basically positive and negative floats. And we can do most similar in Word2Vec. So as you can see here, we're taking this model from up here and then applying it right here, and then using the function most similar. And basically we put in stock, and the most similar word we got to that is earnings before taxes and deductions, or EBITDA, or litigation. As you can see, it's not performing too well on this 10K report. It really kind of matters. There's simpler examples of this where it would work really well, but I just wanted to show you what would happen if we just did it with a random file. And then also we can do like a linear vector model. And basically, so we can show the assets minus the capital minus the cash. And so kind of what I'd be expecting here is you can expect kind of cash or something similar to that would show up. And so what we get here, we get cash, which is somewhat expected. Assets, which we kind of don't want because we're trying to subtract that out of here, but it showed up. So we need to look further into that. And then as you can see here, you get I don't know why December would be there. And then you also get transaction, which I think would be higher up. So you can do some fine tuning and just play around with this model. I just kind of picked it up this week, and it's very dense, so it takes a lot of messing around with, and I'm still not all there yet. Yeah, so we can go back to our slides. Cool. So just to go over basically what we covered, you want to pre-process the data. And then here are some necessary packages that you need to look at for pre-processing. There's obviously some other methods depending on the type of file that you're looking at. And then also the packages for Word2Vec right here. You're going to want to pip install Gensum, and then from Gensum import Word2Vec and keyed vectors. And so further review, you want to first create the array once you're in Word2Vec, and then you want to tokenize the array. And then you want to implement Word2Vec and select the min count and the size. And then also just play around, look at vector representations, look at the most similar words, and then create a linear representation. And then there's further documentation on the other parameters you can use. So it's also important to look further into those. And so here's just a brief screenshot of what we covered. And then here's some other use cases of Word2Vec. so what we covered was kind of find similar words, or you can look at sentences. And then I've also seen examples of finding similar documents. And so you can also use a program called Doc2Vec, and then translate that into Word2Vec through extracting the sentences of that, which for our project we're going to be looking further into. And then you can also use it for recommendations, like on e-commerce sites. This is a pretty common application. And then learning further, like through that document, we're able to learn further about other texts within that document. And so you can think of it as being almost a part of the knowledge discovery process. So you can kind of think back to the KDD process, which was covered earlier in the DePaul program. That's all I have. Here are my sources. Thank you for listening. Goodbye.